Good morning to all. This is Amrish from AAA branch, and today my topic is about field theory and EMC, a short summary on educational aspects. So this is my topic, it about. And coming to the introduction, due to its uh, interdisciplinarity, electromagnetic compatibility (EMC) courses has become a major study in the many electrical engineer curricula, not only in high frequency engineering or electrical engineering, but also for the example in uh, mechatronic engineering, where fundamentals of field theory are not necessarily part of a student's curriculum. Through a large part of EMC lecture concepts is experience based. A fundamental understanding of field theory is mandatory both to explain phenomena but also to develop appropriate countermeasures based on the experience of authors. Simple examples are given and shared. This contribution which turned out to be a good motivation for the students why field theory is experienced essential for their studies as an additional motivation. Relevant EMC scenarios are presented with a base knowledge of field theory is essential for approximate EMC. And firstly, is a metal is a good sheet. So now startingly, in the most of cases, only students but also non-engineers have a very innovatively wrong understanding of how electromagnetic waves or fields can be shielded, because of shielding effectiveness is associated with a material property solely. Of course, material properties, that is the conductivity of materials, is mandatory conditions for a good shield, and in previous courses students learn the tangential electric field components on metal boundaries is zero. However, this boundary conditions is only a result of superposition of induced current and an incident field depending on where those finally flows, which is determined by the shape of the object. The shield might be effective or not. Connected with the typical EMC measurement facilities and equipment, example anechoic chamber, TME cell, spectrum and network analyzer, etc. The effectiveness of shielding can be demonstrated with step up as shown in figure 1. The fact this measurement setup is presented first in to easily demonstrate the shadowing effects of wind turbines in the context of radar and the communication links. Thus students directly can see the benefits for the practical applications. The intuitive answer to the question how the signal strength from the emitting inertia is to receiving the inertia decreasing with the shadow metal piece is a blocked, because is most cases students associated wave propagation with solely optical rays. The metal plate, however, measurements results finally shows the decrease of the signal strength significant and only account for a few dB for the future discussion of the measurement setups. In fact, the same uh, misunderstanding of shielding capability often occurs when shielding cables. A common though is the wrapping up a cable with aluminum foil will significantly improve the shield. However, an EMC specialist knows that a well-defined low impedance connection, thus the termination of the cable, is mandatory. In the lecture, those facts can be shown with the numerical simulations. Example with the programs like 2. The excitation is done with the plane waves and the inner port between the inner conductor and outer conductor of a coaxial cable as simulation example for the introducing such programs and for the understanding shadowing scenarios such as discussed above. Shows the current distributions of a metal block surface as indicates in the insert graph with plane wave incident. It clearly shows that the induced current flows around the structure as well. So you can see this the measurement setup in a TEM cell for demonstrating shield and shadowing effect. And so these are the two diagrams over here for the measurement setup in a TMC cell for. And now is an aircraft is a good Faraday case. The inductive answer of a nearly and student is yes, because they remember the car situation that anyone is protected by a lightning strike within a car. Usually the phenomena of a Faraday cage is automatically associated with a good shield against electromagnetic waves. However, in lectures this phenomena can be successfully discussed with the students as shown with a sketch of think flow as presented in the following figures. It is a mandatory the students can reflect these answers and think about the what consequences follows. For the example, if people answers this initial questions with us, no further EMC testing would be required. In this in this sense, students should think or investigate what EMC tests are performed with respect to aircraft and think they they why they are performed. This is a very important aspect of teaching and should be anticipated in lecture, where probably nowadays for the students is just passing an example thing, just giving a correct answer or formula is sufficient. Now the PCB layout, thinking of currents or fields. In electric engineering curricula, students often learn first, about the voltages and currents when calculating the electric circuit networks in DC or AC analysis. In the specific lectures, they are learned about circuit designs and start using the network simulation tools. Now, for the simulation, the length of wire connection is in the schematic diagram does not matter, since a normal spices simulator takes only the properties of the electric components into account. The use of GND symbols help to create a 3D schematic view with less visible brings to a common ground signal. Nevertheless, students might forget that current flows a closed loop and the area of the loop decides a parasitic inductance for the higher frequencies, smaller wavelength with our respect to PCB dimension structures can even being to radiate the electromagnetic energy. Species simulators neither take automatically inductive coupling nor radiation into account. Finally, a student will build an electronic application that might exhibit performance issues caused from the internal EMC problems and or become the source for unwanted electromagnetic interference EMI. The example shown in figure 4 illustrate a common problem of slotted grounds planes by through holes mounted components. The holes drilled for the resistors are manufactured with on the top of bottom layer. The design rules with given by the PCB manufacturers specific a minimum distance between different signals. Here those rules does not allows closing the layer between the causer slot at each of the two rows of holes. For the relevant signals lines on the top of the layer, path is obstructed and force the current into loops around the resistors arrays. As a result, the incorporate inductance that were not a part of initial spice simulation. And if you see the signal line of interest, the top view of left of a PCB with through a hole mounted resistors, bottom view right shows the slot in the ground plane due to the PCB design rules. So this is the diagram over here. To have a real design follow often to optimize stick simulation result, it is important the designers understands the world of magnetic and electric fields. Neither currents nor magnetic fields are visible for the human eye. A huge advantage in the today's engineering education is the availability of power EM simulation software that allows to visualize electromagnetic fields even for the very complex geometrics and material combinations. In a particular, the concept of inductive coupling needs the insight into the magnetic flux densities as a time varying vector field. Here it's the mandatory that students as well as trained in the vector algebra, differential calculus, and finally the full set of Maxwell equations. The conclusion: some selected topics of EMC lectures has been presented under the educational aspects with the practical examples to the serve motivation for the students why field theory is important, relevant in their studies, and only then appropriate use of integrated measures like voltage or current is possible. Students should always be asked what equivalent in equivalent circuit standard first. So these are the reference books you can study over of this topic about. So thank you for this opportunity.